All right, let's pull back the curtain on one of the most critical, yet almost completely invisible technologies that powers our modern world. It is the silent, steady heartbeat of the internet. And honestly, without it, pretty much everything would grind to a halt. So let's dive into the protocol that keeps our entire digital world ticking. But first, let's just do a quick thought experiment. I want you to imagine a world where your phone, your laptop, the server at your bank, they all disagreed on what time it was. And I don't mean by a few minutes, I mean by seconds or even milliseconds. What do you think would actually happen? It might sound like a small thing, right? But the consequences would be absolutely immediate and, frankly, catastrophic. The orderly, predictable digital world we all depend on would just instantly fall into total chaos. And this really shows you just how bad it would get. Think about it. So many security systems are built on precise timestamps to let you in. If your computer's clock is off by just a few minutes, you could be locked out of your own network. Or imagine a stock trade where a buy order gets logged after a sell order for the same price, just because two clocks were a few milliseconds apart. Total disaster. And for us network engineers, trying to troubleshoot a problem by looking at logs where nothing is in the right order, it's an absolute nightmare. All that critical data from syslog, netflow, SNMP, it all becomes completely useless. So how do we stop this digital time anarchy? Well, the answer is this really elegant and incredibly tough protocol that's been working quietly in the background for decades. And that is the Network Time Protocol, or NTP. So at its core, NTP is all about creating a universal standard for time. It's basically a set of rules that lets every single device on a network, from these huge data center servers all the way down to your router at home, agree on the exact, precise time. And it does this by sending these tiny little packets of information back and forth over UDP on port 123, just to keep everyone perfectly in sync. But you might be wondering, where does NTP get its time from? I mean, it can't just be one single clock for the entire world, right? Of course not. Instead, NTP uses this brilliant hierarchical system. Think of it like a cascade or a waterfall of accuracy, flowing down from the most perfect time sources you can imagine all the way down to every device we use. And this hierarchy is measured in levels called Stratum. The easiest way to think about Stratum is as a measure of trust, or how good your time source is. The lower your Stratum number, the closer you are to that original perfect source of time, which means your clock is considered way more accurate. And this is exactly how that cascade works. Right at the very top, at Stratum 0, you have the absolute gold standard, atomic clocks. These are the most accurate timekeeping devices on the planet. Now, you can't connect to them directly over the network. Instead, they feed their super accurate time to Stratum 1 servers. These primary servers then pass the time down to Stratum 2 servers, which are just one network hop away. They pass it to Stratum 3, and so on, cascading down the line until it finally reaches your laptop or your phone. So what happens at the end of the line? Well, the scale only goes from 0 to 15. If a device ever says its Stratum is 16, that's a big red flag. It's basically shouting, hey, I've lost my connection to the time network. For all intents and purposes, it's unsynchronized. It's on its own. Okay, so within this whole hierarchy, not every device acts the same way. Depending on what its job is, a device can take on one of a few different roles or modes in how it actually handles time information. And this table breaks it down really nicely. You've got your pure server, which only gives out time, it doesn't ask for it. Then you have a client, like your PC, which only receives time. The most common one you'll see, especially in network gear like Cisco routers, is server/client. It gets the time from a better source, and then it passes it along to other devices downstream. And finally, you've got peer mode. This is really cool. It lets two redundant servers kind of keep each other honest, acting as backups for one another. Now, anytime you have a system this critical, it's going to be a target for bad actors. So how do you protect it? Well, over the years, NTP has had to evolve, and a huge part of that evolution has been about security, making sure the time signal can't be messed with. The jump from version 3 to version 4 was a really big deal. As you can see, NTP4 brought in support for the modern IPv6 internet. It also switched from using inefficient broadcast messages, which basically just shout to everyone on a network, to much smarter, more targeted multicast messages. But, the most important upgrade was in security. It added support for much stronger public key cryptography to make sure the time source is legit and can actually be trusted. So, how does that actually work?
Well, on a basic level, NTP lets you authenticate the time packets using something called an MD5 algorithm. This just means a client device can double-check that the time update it's getting is really from a trusted source. It's a simple way to stop an attacker from feeding your network the wrong time. It all comes back to trust.
Okay, so that's all the theory, but what does this look like in the real world? You might actually be surprised by just how simple it is to hook a device up to this massive global timekeeping system. A lot of the time, it's as simple as this one line of code right here. A network admin just types this command into a router or a switch, pointing it at pool.ntp.org. And that's a huge public group of volunteer time servers all over the world. That one command just tells the device, hey, go find the right time from this really reliable place. That's it. And how do they know if it actually worked? With another super simple command, show NTP status. This will instantly tell you if the clock is synchronized, what its stratum level is, and which server it's talking to. It's like a quick and easy health check for your device's sense of time. So what's the big takeaway here? It's that NTP is a fundamental utility. It's just like electricity or running water. It's this invisible infrastructure that you never, ever think about, but it's the thing that allows everything else to work. From secure banking to streaming your favorite show, it all relies on billions of devices quietly agreeing on the time, all thanks to NTP. And that kind of brings us to a final thought. We've just taken a peek into the hidden world of time synchronization. It really makes you wonder, doesn't it? What other silent, absolutely essential protocols are out there, just working tirelessly in the background to make our connected lives even possible? Thanks for joining me.